Our final standard for chapter 1 and 2 is use technology to find prediction equation and correlation coefficient. For the scale, there are actually 4 objectives that make up this standard. They are writing a prediction equation, making a prediction from the equation, finding the correlation coefficient, and then the ability to interpret the correlation coefficient. The scale is very straightforward. If you are able to do one of those things, it's a 1, 2 is a 2, 3 is a 3, and 4 is a 4. Now, this is the point that you will actually need to have a graphing calculator. So if you have not yet purchased one, this standard will be very, very, very difficult, if not impossible, for you to be able to do. Please come find me if you have not yet purchased a graphing calculator so that we can figure out what to do for you. So with this standard, we are going to have a bunch of data, and it's going to be expressed with a correlation, either positive, negative, or no correlation on a scatter plot. So here is an example of a positive correlation. The dots will generally be moving in an upward trend. A negative correlation, the dots will generally be moving in a downward trend. And then no correlation. We will not be able to tell whether the dots are moving up or down. They're just kind of all over the place. Of course, when we're talking about moving up or moving down, we're talking about from left to right. So they're moving up from left to right, down from left to right. I guess it doesn't matter if you're looking at it left, right, or right, left. There's no way to tell which direction they're actually moving. You may have used something like this in science when you plot your data on a graph and then you're asked to find a line of best fit that would be able to make a prediction beyond what your experiment had. We are going to be using our technology to find that perfect line of best fit, or the line that best fits the data. It's far more accurate than using your ruler and seeing if it can go through the points and split the data in half. In order to do that, we've got a little bit more vocab before we get into the nitty-gritty of how to use our technology to do that. First, we have our prediction equation. That is the equation for that line of best fit that we can use to predict beyond the data that's given to us. And then we have a correlation coefficient. The correlation coefficient is a number that ranges anywhere from -1 to +1, and it shows exactly how well the data will be modeled by your prediction equation. Okay, when our correlation coefficient is negative, that means that we have a negative correlation. When it's zero, there is no correlation. And finally, when it's positive, the correlation is positive. And remember, it can be anywhere in that range from -1 all the way up to +1. A -1 would represent a perfect negative correlation. They line up perfectly with the line. A +1 would represent a perfect positive correlation. They line up directly with your prediction equation. Now, in order to use technology, there is a lot of steps that we have to walk through. Here's our list of steps. Once you work through it a few times, it actually will come pretty easily. But please keep in mind that when it comes time for taking your assessment, it will be something that you will have to troubleshoot your own calculator. I will not be able to tell you why your calculator is doing what you are supposed to be doing. Now, if you're working through these steps and working out the problems using these steps, we should be able to fix any errors that you may be getting on your calculator, or any issues that you have with your calculator, because they should be popping up regularly enough that we can get them fixed before the quiz. If you choose not to do any of the problems before you get to the quiz, you're just going to have to troubleshoot those errors on your own. So this is our list that we're going to walk through. I recommend that you have this list out in front of you, because I will not be showing the list. Instead, I'll be showing the data that we're actually working through. So I would have it out and in front of you. The first one should be on a separate page for you so that you can work through the next steps. Now, the steps are split up into what the questions are asking and what the objectives are asking you to do. So the first objective is I can write a prediction equation, and the question that you'll be asked is to draw a scatter plot for the data. The next question that you will be asked is to write a prediction equation. Then finally we have our last two objectives. I can make a prediction from the equation, and the question that will go with that is use your prediction equation to predict the missing value. And then the final objective, I can find and interpret the correlation coefficient. You'll be asked to find the correlation coefficient and then to interpret the results of your correlation coefficient. The question will look something like this. It will give you a table of data, which we have to first put into our calculator. So again, you are following along these steps as I speak them and show what they do. Our first step is our calculator. It asks us to press stat. Stat is located right next to the arrow, the left arrow button. After we press stat, we select option number 1, edit. If you have data already put into your equation or into your tables, you need to highlight the L1 and L2 and press clear. Please don't press delete, because it will delete all of list 1 and that will give you errors. So you're going to press clear and then enter. And then go over to L2, press clear and enter. Again, do not press delete. Then we're going to enter in our data. So we are entering into the L1 column our independent variable. It's the variable that you can control, typically our X values. So a lot of times it will be time in that independent variable. So we're going to press 0 after each of the numbers that we are entering. I highly suggest that you walk through this with me while on your calculator. Make sure that your calculator is showing the exact same thing as I have. If you're not getting the same thing, make sure that you're asking for help. To get to the next row, we're just going to arrow over and enter in the next set of data. If we had had another line here that had maybe 20 and then a question mark, we would not enter that into our calculator. We can only enter our calculator full, complete lines of data. So your lines should end at the same spot. If they don't, you've done something wrong, go back. I cannot tell you enough that you need to double check your data. Just give it a quick look to make sure that it matches exactly what's on the table. Even if you're just one number off, it will throw off all of your answers, and that will require you to have to remediate this standard. So please make sure, because there's not much work to be shown on here, because I can't look at your calculator and find the key sequences that you use. Make sure that you are double checking that your data matches what it's supposed to say. After entering in your data, we are going to go into y equals. If you have anything written into here, go ahead and clear it out. And we're going to take a look and see what our scatter plot should look like. To do that, we need to highlight plot 1. So use your arrow keys to go over plot 1. It should be blinking on it. And if you press enter, you'll see that plot 1 is now highlighted. So if your plot 1 was already highlighted, you can press enter again and it will re-highlight your plot 1. When you move off of plot 1, it should remain highlighted. Once you've highlighted your plot 1, it's time to change your window. So you're going to go to Window, and you can see that our window here is made up of the minimum x value. So remember, x's are our left-right axis. So the minimum x value is -10. The maximum x value is set to 10. And the x SCL, that is the scale that it's going to count by. So it's going to count by ones, -10, -9, -8, and so on. Right now it's set for a y minimum of -10, a maximum of 10, and it's going to count by ones as well. We don't use anything below the SCLs. So just the first 6 options are the ones that we will tinker with. We want to change this so that it matches something in our data. So that means we're going to go to the X minimum value, and we will be changing this to 0 unless we entered in years. So this currently says years since 1985. If it had just said 1985, 1988, 1991, and so on, then we would have changed it to be a little bit below the lowest year. Otherwise, we should enter it in to be 0. Our maximum should be a little higher than the highest x value here. So it's 15. As long as it's a little bigger so we can see the last little dot, we're good. I usually like to go maybe 5 beyond that, so 20. So that means that it will have 20 little hash marks between 0 and 20 if it's counting by ones. That's probably an appropriate amount. If it was 0 to 200, I would not want to see 200 little hash marks across the bottom of my x-axis. So instead, I would probably change that in that case to counting by tens or at least 5, something along that line. Use your best judgment here. Then we have the y's. Now we want the y's to always be set to 0. Then we're going to change our maximum value to be a little bit above whatever the highest value is, which is 20. So again, I'm going to set it to 25. I still don't think it's unreasonable to have 25 little hash marks. My breaking point would probably be if it was anywhere over 30 or 35 hash marks, like a range of that, I would probably change it to count by 2s or 5s, something like that. Once you have completed your window here, you're going to hit Graph. It's the upper right-hand corner. And you should see no lines coming across. You should only see dots. Okay? If you see anything other than dots, please contact me and I will let you know how to fix that. So we've seen what our scatter plot should look like. So on our paper, we are going to mimic that. We know that we counted from 0, and I believe that there are 14 little hash marks here. So you may need to count by something other than ones to match this, like say counting by 2s or something higher like 5s. I'm going to choose to count by 2s. Both directions. Okay, so now we're going to plot the data that we were given. We had one at 0 and 20, 3 and 18, 6 and 15, 9 and 15, 12 and 14, and 15 and 13. We can already tell that it looks to have a negative trend that does match kind of the shape that we had on our calculator, going down steeply and then a less seat more level towards the end. So we should expect to have a negative correlation coefficient. Now let's actually find that prediction equation, because the next step, or the next part or question that it's asking, is to write a prediction equation. So to do that, we'll go back to stat. Remember, that is next to the arrows. And this time we will move over to calc, and we are going to go down to line reg, or lin reg. It stands for linear regression. It is option 4. Hit enter. Now, some of your calculators will look like this, and some of your calculators will look a little different. Here's an example of what a TI-83 would look like, and some of the 84s, depending. It'll just pop up with lin reg AX plus B. Either way you go about it, you're still going to hit enter until you see an equation populate. So it populates with this equation. Even on the other side, the other calculator, you'll still see this pop up. Now, some of your calculators may not have this R squared in R value. So I'll show you in a minute how to get those values. But for right now, let's talk about the A and the B. So we've been given this equation up here, y equals AX plus B. And then we've been given something to plug in for A and something to plug in for B. Please pay attention to what you were asked to round to on the quiz and on the test. For purposes of the notes, we are going to round to the nearest thousandth place. So that means 3 decimal places. So in our prediction equation, we are going to have y equals, and you have to have this whole part, negative 0.44, and pay attention to the rounding, because I want 3 decimal places, so I want to include this 7 decimal place, but this 6 makes it move to an 8. Okay, so make sure that you are paying attention to rounding rules. Rounding incorrectly will mean that you will be unable to get a 4. Okay, then there's an X after that, plus, and we have 19.190, and it can stay a 0 because of the 4. So that is our prediction equation. Turn the page, and the next question asks us to use the prediction equation to predict the percent of students who will send applications to 2 colleges in 2010. Now you may notice that before we moved on our list of directions, it asked us to write down the R value somewhere on the corner of the page because we're going to need it later. So let's use our calculators to make sure that we have an R value. So if you already have an R value, you can fast forward through this part. If you do not have an R value, go through these steps. You are going to press second and catalog. Catalog is at the bottom of the calculator. It's the 0 button. It says catalog in blue above it. Then you will see a long list of things. You need to scroll down until you see diagnostic on. It'll be a little ways, but not too terribly far. So diagnostic on, you'll know that you're there because a little triangle will be next to it. Hit enter until it says done. Then when you go back to find your prediction equation, which just as a reminder, we would hit Stat, we'd go over to Calc, and we'd go to LinReg and press Enter until we get an equation. You will have then your R values show up. Okay, so we're going to jot those down somewhere just to the side so that I can use them later. We don't care at all about our R squared, but we certainly care about that R value. So negative 0.95, and that 8 changes it to a 2. Okay, that's our R. Okay, the next question is asking us to write a prediction equation to predict the number of students who will send application to 2 colleges in 2010. If you look back over to our table that we were given, the X values are the numbers since 1985. So 2010 would be how many years since 1985? 25 years. So we need to figure out what happens when 25 is plugged into that long, nasty equation that we saw before we rounded. So to find that out, we can do a couple of things. You can type all of those numbers in and then plug your 25 in for X, or you can follow the steps that are written on your page. That should be under the bolded portion that says to use your prediction equation to predict a missing value. We'll go back up to that Y equals. Then we are going to hit VARS. VARS is underneath the arrows. I should mention that before you do this, the very last thing that you should have done in your calculator was find the prediction equation. If that wasn't the last thing that you did, go back, go through that step to find the LinReg, and then go through these steps. So once we are at VARS, we are going to arrow over to Statistics, option 5, then EQ, and select Reg EQ. That will take our regression equation, copy and paste it into our Y1 value. Now that's important because there is a function on here called a table. If I press second in the graph button, it will show me the T-chart for the equation that I just put into that Y equals. We want to know what it is for 25. Now it's not that big of a deal for us to scroll down to 25. It's not that far away. But if it was, say, wanting to know down to 100 or 300, we wouldn't want to sit here and waste our valuable time pressing the arrows. So if we use second and table set, it will get us back to a place where I can tell it where to start. I want the table to start at 25. That's the only value that I care about. So I'm going to change my start value, my table start value, to 25. Then I'm going to go back to the table by pressing second table. And I have that at 2010, which is 25 years after 1985, the answer was 8% of students. Then part D is asking us for the correlation coefficient. Remember that R value that we wrote down? That's our correlation coefficient. And finally, we have been asked to interpret the results of our correlation coefficient. If you look at these steps written for your calculator, underneath I can find and interpret the correlation coefficient. Number 2 tells us the steps or the interpretation of it, the correlation coefficient. Values that are between 0.9 and 1 or negative 0.9 and negative 1 are considered strong and accurate models. And we need to say why. R is in between 0.9 and negative 1. Sorry, negative 0.9. And then we also need to indicate that the correlation is negative. And that's because R is negative. So the correlation coefficient, to interpret it, we need to say whether or not it was a strong and accurate model and why, and then indicate the correlation of the data and why. Let's walk through one more example. This time it's going to move a little bit quicker without all the explanations, but still walking through the steps. So we need to enter in our data. To do that, we'll go to Stat, we'll Edit, then we'll clear out the data that's there by highlighting it and pressing Clear and Enter. Highlight it, press Clear, and Enter. We'll enter the left column of data into the L1 column. I will not enter in 2015 because it does not have a completed line of data. It has a question mark over here. When you're finished, take a moment to go through and double check that your data is exactly matching what was on the table. Once you've done that, you're going to hit Windows, Once you've done that, you're going to hit Window. Then we're going to change our window to match what we have in our data. This time it's listed in years, so I don't want to put 0 for my minimum. I want to put a little bit below the earliest year, so that was 1970. So we'll start at 1965, and it goes all the way up to 2002. So we'll go a little beyond that to 2007, or you could put 2010. It's probably on the bubble here whether you want it to have it counting by ones or something larger. I'm going to choose to have it count by fives. And then our minimum value will always be 0 for Y, and the maximum value will be a little bit over the highest one. So we'll go to 52,000. We definitely don't want it to be counting by ones in this case. I would say that counting by thousands or even 2000s would be far more appropriate. Make sure that your Y equals is cleared and then hit Graph. So there's our data plotted. That would match whatever you have plotting for a scatter plot on your paper, which this one I don't believe you need to plot on your paper. Next, we're going to find the correlation or the prediction equation. So we're going to go to Stat, over to Calc, select option 4. Press Enter until you get an equation, which for this one, our equation is y equals, here is our A value, 1, 2, 3 decimals off, and the fourth decimal says that the 7 can stay. So 1,349.867x plus, and here's our B value, which is already rounded for us to 3 decimal places. You don't have to write plus minus. If you want to leave it as plus minus, that's fine. Or you can change it to just minus. Either one is fine with me. So there's our prediction equation. Again, we're going to be careful to write our R value over to the side because we know we're going to use it later. Rounding to the correct number of decimal places. Then we need to use our prediction equation to actually predict a value. So we're going to go to y equals. Then we're going to use vars, statistics, EQ, reg EQ. And we want to predict 2015. So second table set 2015. And then go to our table, second table. So in 2015, my answer should be 69,214. Then it wants to find the correlation coefficient. That we already have down here. And now interpret the correlation coefficient. It is between 0.9 and 1. It is a strong and accurate model, and because it's positive, it is a positive correlation.